Welcome back to Think Thrice Problem Solving. Today we're going to be solving a fun little problem. So let's take a look. So our problem says that we want to find values of k and m where the sum of the first k minus 1 digits, so we have a sequence going from 1 up to m, so m is our maximum in our sequence and k is some value in between. And we have the sum of every digit before k is equal to the sum of every digit after k. So if you'd like to pause the video and give this a try, please go ahead and do so. Otherwise, let's go ahead and jump straight into our solution. So going in, all we really know is that the number of digits to the right of k is definitely going to be less than the number of digits to the left because their values are all greater. But we can't tell too much beyond that just by looking at this. So let's go ahead and work through it. So first, I want to notice that if I have a sequence that goes from 1 up to n, so we're going to go up to n minus 3, n minus 2, n minus 1, n. If I wanted to take the sum of the first n digits, then what I can do is I can look at the first term and the last term and add those up. So it's going to be n plus 1. And then I can multiply that. So what I notice here is that n plus 1, so these first and last digits, their sum is going to be the same as the sum of 2 plus n minus 1, which is the same as the sum of 3 plus n minus 2, which is the same as 4 times n minus 3. And what I'll discover here is if I multiply this by n over 2, so the number of sums that I'm taking, then that's going to give me the sum of all of my numbers. So we're going to use that fact. So if I look at my sequence above, if I wanted to take the sum of the first k minus 1 digits, then that's going to equal, just using the equation we just came up with, I'm going to get k minus 1 plus 1 times k minus 1 over 2, which is going to be equal to k times k minus 1 over 2. Okay. And now, if I wanted to get the sum of the k plus 1 to m, so the sum from n equals k plus 1 up to m, so all of the digits from k plus 1 up to m, then what I'm going to do is I can take the sum of all of the digits up to m, which would be m times m plus 1 divided by 2. I could subtract k, because k is not included, and I could also subtract that value that I just came up with. So I can subtract all of the digits up to k minus 1. And that's going to give me the total of just the sum of k plus 1 up to m. So now let's go ahead and look at what we're actually doing here. So what we're trying to do is make the sum of the red numbers equal to the sum of blue. So to do that, we're going to take k times k minus 1 over 2, and we're going to set that equal to m times m plus 1 over 2 minus k times k minus 1 over 2. So I notice that I have the same thing on the left and right. So if I add that from the right to the left, that's going to be twice it. So I'm going to end up with k times k minus 1. I'm going to add k because I'm adding that guy over here. And that's going to be equal to m times m plus 1 over 2. Now, I notice that I have k squared minus k and then plus k. So this guy and this guy are going to cancel. So I'm going to be left with just k squared is equal to m times m plus 1 over 2. So what does that mean? That tells us that m times m plus 1 over 2 is a perfect square. Okay? So that's what we're looking for. So we're really looking for numbers where m times m plus 1 over 2 is a perfect square. So let's check for them. So let's try to find a solution. Let's make a little table here. So if I have m here and m times m plus 1 over 2, if I start taking numbers, we're looking for m times m plus 1 over 2 to be a perfect square. So if m is 1, then m squared plus 1 over for us m over 2 is going to give us 1, which is not a perfect, which is a perfect square, but we need k to be less than m. So let's try 2. So 2 times 3 over 2 is going to give us 3. Let's try 3. 3 times 4 over 2 is going to give us 6. Let's try 4. 4 times 5 over 2 is going to give us 10. Similarly, for 5, we're going to get 15. For 6, we're going to get 21. 7, we get 28. And 8, we get 36. So we found a solution. So notice that this value here, 36, is a perfect square. So what does that mean? That means that if k is equal to 6, which is the square root of 36, then m is going to be equal to 8. So let's go ahead and draw out what that means. That means that our sequence is going to look like 1, 2, 3, 4, 5, then our k value, which is 6, and then our values of 7 and 8. And what we notice is that if we take the sum of the first 5, that's 15, and if we take the sum of the last 2, it's also 15. So we found one valid solution. So now what I'd like to ask is this unique? So is this unique, or is there another possible answer? And we could get on a computer and kind of obliterate through these, but let's go ahead and try to make it a little bit easier for us to find a solution. So what we notice is we have m times m plus 1 over 2 is a perfect square. So what does that mean? So if that's a perfect square, then I'm going to be multiplying something by itself to get this. So what that means is that either we have a case 1 where m over 2 is a perfect square, some number squared, and m plus 1 is some other number squared. Because if you think about it, we're going to have the same number of prime numbers that are multiplied together here, and that's only going to work if we have those equal to some sort of perfect square. So if I plug this into my second equation, I'm going to end up seeing that I have 2a squared plus 1 is equal to some other perfect square. All right, so then I could have a second case, and in the second case, I could have m equal to some perfect square, and m plus 1 over 2 is equal to some other perfect square. So in this case, I would have 2b squared minus 1 is equal to a squared. So what we can check, if we notice from these two equations, what we really have is 2 times some number squared plus or minus 1 is going to be equal to some other number squared. So let's find a and b so that 2a squared plus or minus 1 is equal to some other number squared. All right, so this will kind of make it a little bit easier than our original equation. So let's go ahead and try this out. So just like above, let's make a little table. So let's make a, and then let's make 2a squared. Put those in here. And let's try it out. So first, let's try 1, and I get 2. And I'll notice that that does kind of work, but that's the trivial case. Let's try number 2. So if I have a equal to 2, then 2 squared times 2 is 4, or 8, plus or minus 1. So I'd have 8. And I notice that 8 plus 1 equals 9, which is a perfect square. So this actually is the first solution that we found above. So this is just another way for us to find that first solution. If we keep going, where if we plug in 3, we get 2 times 9 plus or minus 1. So we get 18. That's not plus or minus 1 of a perfect square. If we try 4, we're going to get 4 times 4, which is 16 times 2, which is 32. And that's not within 1 of a perfect square. But if we try 5, we're going to get 50. And we notice that 50 is equal to 49 plus 1. So what does that tell us? That tells us that this is one of our solutions. So now we have one of our solutions where m over 2 is equal to a, which is equal to 5, and we also have m over 2, sorry, is equal to a squared, which is 25. And we have m plus 1 is equal to b squared, which was 49. Okay, so let's go ahead, or m plus 1 is going to be equal to b squared, which is 50. Okay, so let's go ahead and work through this. So we can see that m is going to be 49 from here. Or sorry, I made a slight mistake here. So we have m plus 1 is equal to 50, and that's what gives us. So m is going to be 49. So that was what we came up with above. So I was just plugging that in directly. So we have our m value, and remember, we wanted to find what our k value was as well. So if we go up, we can see that we have our work up here, where we calculated our k value in terms of our m value. So k squared is m times m plus 1 over 2. So let's go ahead and find out what our k value is. So k squared equals m times m plus 1 over 2, which is going to be equal to 7 times 7 times m plus 1, which is 50. So 7 times 7 is that 49, times 50 divided by 2, which is going to be equal to 7 times 7 times 25, which is 5 times 5. And we notice that we're squaring 7 times 5. So k is going to equal 35. So I found now another m and k value which will work in our equation. So if I have the sum 1, 2, up to 34, and then I have my 35th value, and then I continue and I go 36 up to 49, I'm going to end up getting that the sum of these digits on the left is exactly equal to the sum of these digits on the right. So what we've just shown is that our original solution is not unique, and it turns out that if we keep going, we will be able to get many, many more solutions to this problem. So thank you very much for joining me in this solution. Sorry it got a little bit scrambled there toward the end, but I fixed it up. If you enjoyed this video, please like and subscribe. If you have a problem that you'd like us to do on the channel, please go ahead and submit it, and we'll work through it and post it. And remember, as you're working through your own problems, if you start to get stuck, think again, and if that still doesn't work, then try thinking thrice.